will be discussing all these behavioral design pattern which fall under the third category in Gang of Four book. We have already looked at the creational and the structural design patterns, so I'm creating this series to cover all these behavioral design patterns. So the first pattern which we will discuss in this video is the chain of responsibility design pattern. So we will define what is the chain of responsibility design pattern. We will take a look at the problem it is trying to solve, and then we will do a live coding example where we will implement this chain of responsibility design pattern. So before moving on, I would like to show you the problem, what happens, and how the chain of responsibility solves that problem. So let's take a look at this piece of code. So in this piece of code, I know it's very daunting to see this kind of code where you have all these if else if ladders, and each ladder is expected to do a well-defined job. So here we have a variable called incoming suspect which is given a value, and based on this value all these handlers, or you can say ladders, are doing their job. So if it's a civilian SUV, it's doing a validate ID, do exhaustive search, and do minor interrogations. If it's a fire truck, it's doing something. If it's an ambulance, it's doing something. So you can see, right, every operation is dependent on the other check in a sequential manner. If the first check fails, to the second one. If the second check fails, to the third one, and so on. So when you encounter this kind of situation, right, it's very instinctive or natural to write a code like this, like you write if else. But the problem with this kind of code is the more ladders you add to your code, the more complexity you are increasing for your code, and it will become very hard to actually debug your code and actually read it. So we write code for people to understand it and make modifications to it. If we write a code like this and people are not able to read it, it will be very hard to maintain. So that's how chain of responsibility comes to rescue, and we will see it how does it do that and lets you write good code. So let's look at the chain of responsibility definition. So the definition says it's a behavioral design pattern which tries to avoid the coupling of sender of a request to its receiving objects and change the receiving object and pass the request along the chain until an object handles it. Well, the definition seems quite simple to me, but you need to understand that what is the request which is coming, why do you want to change the request handlers, and why do you want to propagate the request into the chain until one object handles it. So coming back to our old example which I show you, which was a bunch of if else ladders, and there was a string which was the parameter which was called the input suspect. So in our example, the input suspect is actually the request, and all those if else ladders are the handlers. So you can imagine a scenario like your request is coming, right, and every handler is doing its own job and checking whether that handler needs to be invoked or not. So it's like a handler chain only, but it's represented in a form of if else ladder, which is not bad, but in the long run, if you add more handlers to it, you will have more if else ladder, which will make your code not readable. That's why the concept of propagating the request object to the receiving objects in a chain of handlers came, and this is where the chain of responsibility principle comes to the rescue. So let's look at the UML diagram for this chain of responsibility pattern, and then we will try to refactor our code which we saw in our example and then make it cleaner so it looks good and follows the chain of responsibility. So since now you have understood what is the problem this chain of responsibility design pattern is trying to solve, let's take a look at the UML diagram for this pattern. So the UML diagram is also quite simple. We have a handler interface which has two methods, set next and the handle request. So what this set next method, you can assume chain of responsibility design pattern if you are familiar with the linked list data structure, where every node in the linked list is a handler and which will provide its own implementation to handle the request. So extending this handler, this base handler has a reference to the next handler, and it has a method to set which it implements from the interface, and it also provides the method to handle the request, because since it is implementing from a handler interface, it needs to provide implementation for these two. But since this base handler can be an abstract interface, so this handle method implementation can be provided by the concrete subclasses for the handlers. So let's see this in action now. So this is where I have coded that UML diagram, and to maintain a one-to-one mapping, I have kept it exactly the same. So we have here a handler interface which has two methods called setNext and handle. Similarly, in our Java interface, we also have this handler interface, and we have two methods, setNext handler and handle. We have a base handler which is implementing this interface handler. So for that, I have created an abstract handler which actually implements the handler. It has a next reference to the next handler which we will be delegating the call to. So here we have the next handler, and it also provides an implementation for setting the next handler. So we have the implementation for setting the next handler in the chain. Now we see that there are multiple concrete handlers with implementations to this handle request. So let's look at our old code which was cluttered. So here we see that we have different handlers for different kinds of incoming suspects. So if it's a civilian SUV, we have to do some logic. If it's a fire truck, then we are doing something. If it's an ambulance, then this. If it's a police SUV, then this, or else we are stopping it right there. So we can also throw exception here. So I have created for each of this handler, I have created a subclass implementation for this abstract handler and actually put this logic inside that handle method. So let's look at one of these subclass handlers. So for civilian SUV, I have created this civilian vehicle handler, which obviously gives the implementation for the handle method. And you see, right, I have exactly copied what this civilian handler was doing here. So I have copied this block and moved it to civilian vehicle handler. So if the vehicle type is of civilian SUV, we will handle that and return, else we will delegate the call to next handler. So this is where we are delegating the call to the next node in the linked list, you can say. So we have a linked list of handler nodes. So every node will try to handle the request. It will check whether this node is able to handle the request or not. And if it is not able to handle, we will just route the request to the next handler in the chain. So we have different handlers. We have ambulance handlers, which also has the same logic. Similarly, we have fire truck handlers. We have police SUV handler. So let's look at the main method which drives all this in action. So I have created one get validation handlers method in the main method, which is not doing anything but creating and populating the chain. So our first object in the chain is the civilian vehicle handler. What I'm doing is creating 4 handler objects called civilian handler, fire truck handler, ambulance handler, and police SUV handler, and then adding fire truck handler at the back of civilian handler, then ambulance handler at the back of fire truck handler, and so on, and returning the head of the list. So we are using this utility method to actually generate the chain of handlers. Now, after getting the chain of handlers, what I'm doing is, given a vehicle type, I'm just calling handler.handle. So you see the complexity is gone now. Even if we go to the handle method, we go inside, we see that it is not completely tightly coupled to this handler because it's an interface. So depend on abstractions instead of concrete implementations is a good practice, and we are following that. So our code has been completely decoupled from the handling logic, and each of the handling stays in its own area. So if we run this code, it will be producing the same output as we'll be getting with the handler. So you see, right, that the flexibility of the code is maintained. Even if you want to new handlers, you just don't touch the old handlers. You only need to create new instances of these subclasses and add it to the linked list nodes. So that's it with the chain of responsibility design pattern. I hope you have understood the idea behind it and you are going to implement that in your next coding session whenever you get a valid cause. So thanks for watching this video, and I will see you in the next one with the command pattern.